Heartiest welcome to NASA Space App Challenge 2023. Greetings from Team Recursion. I'm Jayantika Sinha and my teammates are Riyadul Haq, Papri Shen, Mohammad Shahid bin Rafiq and Abhirup Datto. We are working on the challenge Develop the Oracle of Discover. Let's take a tour and tell you why we have selected this challenge. The sun is warm, bright and pleasant except when it suddenly releases composition of plasma and radiation in the solar system. The solar flares and CME rape million or billion tons of plasma from the sun's atmosphere that speeds off up to 9 million km per hour. As the magnetic cloud passes over Earth, it stretches the Earth's field into a long tail and the tail explosively releases its energy towards Earth. This is called geomagnetic storm. The Earth faced such storm several times. The Carrington event produced one of the most powerful solar flares ever recorded. It resulted disruption to telegraph system. Modern society is vulnerable to such solar storms which could potentially disrupt power grids, satellite communications and internet apocalypse can happen. The blackout may take 16 days to 2 years to recover. In 2015, NASA launched the Deep Space Climate Observatory or DSCOVR to provide early warnings and forecast of space weather events that could potentially disrupt satellite communications, power grids, and navigation systems on Earth. DSCOVR orbits in Lagrange point 1. This position allows it to have a continuous view of the Sun and sunlit side of Earth. DSCOVR carries three main instruments: Faraday cup to measure the density of solar wind particles, EPIC to take images of Earth in 10 different wavelengths of light, and NISTR to measure the amount of radiation coming from the Earth. The instrument has long experienced grounding faults and possibly other issues that introduce noise, transients, harmonics, and other ugliness into the signal. That's why we came up with a solution. We are offering two-tier approach for DSCOVR's raw dataset. One tier is data filtering and trimming. Here, we have to collect raw data of DSCOVR from NOAA and start initial processing. From the dataset, we have to remove the non-relevant columns, and the columns where there is null data, we have to include apposite data. That's how we will complete imputation. In the dataset, we will implement wavelet transformation, which will be used to remove noise in the data. After that, we will be mapping the data by using DTW algorithm and make sure that the data is sequentially aligned. The second tier is about analysis and predictive modeling. The machine learning model LSTM will be used to train our model. We will compare the value that we got from training dataset with the ground truth values. Then we will quantify the accuracy of our neural network prediction compared to the ground truth by calculating R-square MAE. Our project name is GeoMagGuard. We will use NASA's API to visualize space weather indicators. We are proposing an app named GeoMagGuard where prediction of solar storms and warnings will be available, and as per intensity of geomagnetic storm, precautions like unplug power surges, avoid travel, stay indoors will be provided to users. Developments in space weather forecasting would enable people to plan better and avoid the most serious impacts of solar storms. Our project will conserve the environment. Thank you for being with us.